So you might have noticed, right, as a beginner, that as you're following along with a modeling tutorial, that your mesh starts behaving really weirdly. And things that the tutor are doing seem to be very simple, but when you try and do them, they just don't really work, right? And it kind of starts diverging between what the tutorial is doing and what you're able to do with your mesh, right? This is really, really common. It's a very common beginner problem, and this occurs basically because you accidentally press the wrong keys in the wrong order. And what ends up happening is that you finalize commands that shouldn't be finalized and you create some form of invalid geometry inside of your mesh. And then that has this cascading knock-on effect that prevents all of your future modeling efforts from sorry, sorry, something in my throat. Prevents basically your ability to continue modeling, right? So that's what I'm going to talk about in this vid. I've I just kind of call it mesh integrity. Not really sure what the official term is, but basically this video is going to be a guide on what we consider to be good or bad geometry, right? And in what is in general considered like valid geometry. Sorry, there's something stuck in my throat. So basically, this chapter is going to be very dry, right? But I'm going to explain to you essentially why your meshes fall apart or why they become invalid and unworkable, right? And then after this, we'll move on to more modeling. Okay, so mesh integrity sort of refers to the fundamental, like structural soundness of 3D geometry, right? It encompasses sort of the basic requirements that make a mesh mathematically valid and technically functional. So we're looking for things like manifold surfaces, we're looking for proper surface normals and face geometry, and the absence of things like degenerate geometry, right? And I'll explain what these terms kind of mean in a little bit. Um, there's a distinction between mesh integrity and topology, right? It's in the same sort of like theoretical ballpark, right? Like mesh integrity can be considered a subset of topology, but they have two distinct like purposes, right? So when we talk about mesh integrity, we're talking about sort of the non-negotiable foundation of everything you're going to make, right? Your faces need to have proper orientation at normals. Your models themselves need to be valid geometric structures, right? And without this, the entire downstream process falls apart, right? Whereas topology, when people sort of say topology, they more mean the placement of edge flow, the placement of edge loops, making subdivision surface friendly geometry, making animation ready geometry that can deform properly, sculpt ready topology, like these sorts of things, right? So there is a critical distinction between the two. And I do want to stress that you cannot create meshes that function in this field without having a solid grasp of mesh integrity, right? Um, a mesh with integrity issues is just going to fail when you start to like render things or animate things, or especially in 3D printing, right? The processes just kind of fall apart, right? So I wanted to make that little distinction before we get into the thick of it, right? So something I want you to start doing is that from now on everything that you make, I want you to ensure up here that you turn face orientation on, and that you click over here. So this first thing is the viewport overlays panel, I'm sorry, so face orientation on there, and then over in the viewport shadings drop down, we want backface culling turned off, right? The reason I want it turned off is because I want you to be able to see the errors, or not the errors per se, but I want you to see the backs of your mesh rather than seeing through the mesh, because that can be a little bit confusing, right? In previous versions of Blender, turning face orientation on and leaving it on is a little bit unviable because it colors all of the front-facing polygons a very bright blue. So if you are using a previous version of Blender, like an earlier one than 4.43, you can sort of toggle face orientation on and off as you see fit, but going forward for all the newbies with the new versions of Blender, you may as well just leave this on because all it does is change the back, like the back face coloring, right? So when we're working on a mesh, I want to highlight a few things, right? There's this concept that I think of in my mind as where there's smoke, there's fire. Okay, so there's sort of these like visual warning signs, and you've sort of seen a couple as I've turned this on. We can see that there's like red showing through our model, and there's like these weird like flickering problems here, right? If I were to turn off face orientation and leave this model, some of these don't really show as problems, right? Like this big face here looks totally normal, but then when I start turning face orientation on, it starts flickering and breaking, and there's red stuff showing everywhere, right? So there's this idea, right, where there's smoke, there's often fire. Okay, so that we want to learn what the smoke looks like, sort of, when we're working. So if I select this Blender object, oops, sorry, let me get back to there. There's a couple things that are going to show up, right? I can see obviously there's flickering, on some of my faces, I can see that there's these weird orange lines that go through some things. And I don't know if you can see this, I don't know if it's going to show up in the video or not, but there's a little there's a little yellow sort of dot here, and you can see that that dot matches the exterior line that I've selected. Normally the exterior line would only really show on the outsides of the meshes. It shouldn't show here and it shouldn't show here. And it certainly shouldn't show here also, right? So these are all little bits and bobs that should start tipping your brain off that there's actually something really wrong, right? There's also this idea that like selections might not really highlight properly, right? So if I select a vert in Blender, we can see that from this point there's sort of an orange glow that moves off from this vert to the neighboring verts, right? That's basically going to happen if we're in vertex mode. If we're in edge mode, it's not going to happen, and if we're in face mode, it's not going to happen, right? But if I start going through and selecting faces, do you see how here on this left side here we don't actually see this orange glow continue off to the neighboring connected vert? We actually see that it sort of abruptly stops here. It kind of goes off to the top one, but it sort of abruptly stops here, and there's a bit of an aliasing problem here, right? This should be like an alarm bell in your mind going off that there's something wrong with this edge. We can also see that if I look at the thickness of this edge here, right, and compare it to the thickness of this edge here, that these edges actually seem like thicker almost. There's like a slight like increase in darkness with them, right? These are the things you want to be looking for. These are like the fire alarms, the things that are going off, right? There's other things too, right? So typically in Blender, if I select one vert and then another vert, I can hit J to slice a line sort of between them, right? But if I select, say, this vert, and again we see that weird selection thing where it's only working one way but not the other. If I select this vert and another one, like somewhere down here, I should be able to slice between these freely by tapping J, right? But if I tap J, I get this like error reported window, and it says could not connect vertices, right? So that's sort of another like sign that there's really something like majorly wrong in here, right? The other one as well, really common, is that loop cuts, right? If I press Control R, sorry, let me turn my screencast keys on here. Event history, yep. So if I press Control R and mouse over edges, normally I'd be able to send loop cuts through things. But you can see up here, I'm not able to send loop cuts like the whole way through this mesh. And we know for a fact that we expect that with things like triangles and n-gons, but not necessarily with quads, right? And if I look at this face here, well, I was going to point out that if I look at this edge and this face appears to be a quad, and this is a quad, and this is a quad, a loop cut should go straight through here. So if I press Control R, we would expect it to come all the way through. Sorry, I had to mute for a second. I must be coming down sick. So we would expect that to come all the way through, but it doesn't, right? And if I transition into face select mode, and I click this face, that's sort of a telltale hint that there's like a larger problem here, right? So this is your first step in identifying whether or not your mesh is valid, right? Is that you want to start recognizing the subtle signs, the subtle hints that things are broken, okay? Now I'm going to explain exactly like what things are that we consider broken, right? If I take this vert and I duplicate it off to the side here, and I just have a vert floating around in 3D space like this, we would consider this invalid. This is invalid geometry. It's not doing anything, it doesn't contribute to any faces or anything of that nature, right? Same as a floating edge. We're here to make 3D models, right? So 3D models, that means that by definition, the minimum 3D model that we're going to make ever, really, is going to be a surface. It has to have a face, at least one face, right? So this here is a structure that we would consider invalid. But the minute that we open this up and create a new triangle, this is no longer considered invalid. This is just a triangle that's floating off in space. Now this would be an error if we didn't want this here, but you know, for this example, I do want this specifically here. So this isn't invalid or anything like that, right? So yeah, floating edges, floating verts, big no-no, right? The other one is going to be something called a T-junction, right? So if I try and subdivide this plane a little bit, and I were to get rid of those, collapse these, alright, and I just smush these together. Again, this looks like a piece of valid geometry, but we start to see the thickening of this edge here, and if I try and run edge loops, it doesn't go the whole way, right? This is essentially called like it's sort of like a T-junction where this edge comes up to these two edges, creating a T, but it doesn't actually continue onto the next like polygon, right? And typically that would be removed, and we would see it maybe something like this. So this is called a T-junction, and it basically puts a hole in our mesh that we're not really keen on having. And we can have holes in meshes, right? But only if we design them by intention, right? If I extrude all this the whole way down, and I press XF to open this up, this is called a boundary edge, right? Now, boundary edges, they're sort of like they open the 3D model's internals up into the larger world, like at large, right? This is a form of non-manifold geometry. That's the key word here. But open boundaries are interesting in that they are non-manifold, but they're actually, like, we often use these intentionally. So if you place an open boundary, like with intention, that's completely fine. That's not really considered invalid. But in the case of the T-junction example, we didn't mean to put that boundary there. It should have clearly, that polygon should have been closed and moving like vert to vert, right? So that's kind of the key point with open boundaries, is that if it's done on purpose, then that's fine. But if it's done accidentally, that's a big problem, right? Because it leads to greater issues elsewhere, right? I'm also going to make something here called a bow tie vertex, right? So the bow tie vertex is essentially a triangle whose edge comes down here and connects with sort of the outside of another mesh, I guess you could say, right? Like this surface without this triangle, this is the natural sort of exterior of this surface, especially if I close up that boundary edge. This shape now has an unambiguous inside versus an outside, right? The minute that we weld geometry like this in, give me a second, it now becomes impossible to really know which side is outside and inside, right? If I delete this face, it's very easy to know which is inside and outside. But with this face attached, the computer can't really tell which side of the shape is inside and outside, because this here is a part of the shape. And you know, it's kind of hard to really, I guess, explain, but intuitively it sort of makes sense if you think that, like, this polygon has two sides and we're not exactly sure, right? Like, if that's pointing that way, what if it was rotated this way? Is the outside that way, or is the inside this way? Doesn't really make sense, right? So this is called a bow tie vertice, or a bow tie face, whatever you want to call it. I guess the idea being, you know, sort of looks like a bow tie, right? Let me just finish that off there. Okay, so we've also got edges with three faces, right? Edges that share more than three faces. This is a little hard to explain, but if you look at any edge, like any edge in the world, this edge here can only possibly ever be shared by two faces, right? Same with this one, 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 right? Because, you know, it connects two verts end to end, which then creates a loop between two polygons. Like, sort of, if you can think about it that way, I guess it's impossible for any edge to ever be exposed to more than two polygons, or at least it should be normally, right? If I extrude this edge down, well, now suddenly this edge here links to this polygon and this polygon. This is very similar to the bow tie edge, right? The bow tie polygon. And you can see here, I can keep extruding these out all day, right? These are considered completely invalid. You would never ever make geometry that looks like this, right? I can't think of any exceptions. Essentially, with a rule, it's almost without exception, right? So these are edges with more than two faces, right? We also have interior faces, okay? So if I go into this object and everything becomes like super red, right? If I select the bottom face and the top face and hit F, I can create, I call it like wormhole geometry, right? It kind of links one side to the other. This is an interior face, right? And again, when our camera's inside of this object, the logical inside versus the logical outside makes a lot of sense. But in this case, well, which side's inside and which side's outside, right? It's kind of actually impossible to tell, because this polygon has, you know, a backside and a front side, and it's contained within a larger object, so which side's truly in and out, right? Doesn't really make sense, okay? In terms of vertices, there's something called a coincident vertex, right? So if I have a vertex here, and I just place it on top of another one, right? This here actually contains two vertexes, right? And if I click one, you can kind of see that issue before, where in this case it's highlighting orange off to the side, but whether or not this vert's selected actually keeps flickering from black to white, and that's because there's a second vert here. This is called a coincident vertex, right? Multiple vertexes at the same location. So if I select all of these and hit Shift D, sorry, and then enter, I've placed a bunch of coincident vertexes here. Okay, so that's not good, right? What else do we have? I'm just reading off my notes as well at the same time, sorry. Duh, 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 duh. There's another, another type of coincident vertex, right? It is functionally the same thing, but I want to highlight something. If you're using extrusions and you decide to extrude this out and you go, oh, actually, I don't want to do that, and you hit escape, you'll notice that this face, when we're in face selection mode, actually now has these like dots here. Dot, 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 so on and so forth, right? Because we didn't actually cancel our extrusion, we just sort of cleared it, but you can see it's actually still got the geometry here, right? So if I Control Z this, if I grab this whole face and try and move it, the whole set moves. But if I extrude, and then I think, oh, I actually want to bail out of this, I'm going to right click to cancel, and I move it again, it's actually put a whole new set of geometry here, right? So this is still coincident vertices, but there's also a hidden face in here, right? If I go into face select mode, normally I would be selecting faces. I could select this point here, and that's showing me that I'm selecting an edge, but what I am actually doing is selecting a face. If I go into edge mode and click that edge, I can then move that off, leaving behind sort of the sibling edge to form that polygon. You can actually see there's a whole bunch of polygons in here, right? So we would consider this, this is also an error, right? What else do we have? I guess we'll move on to face problems, right? So normals and normal inversion is a very common one, which is sort of why we're turning face orientation and we're leaving it on. We can see that if I look down here, the normals for this plane, this incredibly busted plane, is pointing actually in many directions at once. The red side's pointing down, and then it's Z fighting with the sort of upward facing faces, right? So this is sort of an example of like normals that are just pointing in the wrong direction. I could also select these here and do flip normals, and that forces these normals to be in the opposite direction. Waters should be, in general, manifold, which means that they are sort of naturally enclosed in a watertight surface that has, I think the technical term is like a standard Euclidean representation, something like that. I'm not a mathematician, but the basic idea is that, yeah, everything should have a clearly delineated inside and outside, right? If you start modeling and the normals start flipping around, that sort of violates that principle, right? Now, there are totally legitimate reasons to do this, but again, this is about like accidentally making mistakes. You don't ever want to do this by accident, and this is going to naturally happen as you're a beginner and you're not like inputting the commands perfectly correctly, right? One of the other errors that we have is something called a lamina face. This is actually kind of hard to force in Blender, but I'll try and show you. Basically, the idea is that if I was to stack these two faces on top of each other by scaling them sort of to nothing, right? And then the idea is we would then want to remove these internal faces. Like if you can imagine, this is valid geometry, this is valid geometry, this is starting to become invalid geometry depending on how it triangulates. And if I collapse this now, this is definitely invalid geometry because there are two faces stacked on top of each other. Thankfully, Blender is actually smart enough to clear that extra second face, and it just leaves behind a quad with a front and a back. But this is going to happen from time to time, where you end up creating something like this, where it's actually... See, it's incredibly hard to actually force Blender to make this error, right? But you end up with two faces that are stacked on top of each other with normals pointing in opposite directions, right? It will happen, you'll see it eventually, but just try and keep it in mind. The other one is, we showed it before, right? When I, let me just recalculate this outside because it's getting annoying. When I extrude and then I clear by accident, I've dumped the extrusion at, you sort of know, offset, right? So in face mode, we can see that there is still faces here, tucked in here. These are like zero surface area faces. These are faces that have been scaled in such a way that they now have like no surface at all, right? So that's basically an error. If we're going to make a face, if we're going to describe a face, it should have some level of surface area, even if it's really small, right? Teeny tiny. The other one would be scaling this face to nothing, right? It looks like it's all been scaled to a point, to a single vertex, but it actually hasn't. There's still a face hiding in here. And you can see as I pull the verts out, right, we end up getting that, like that's sort of revealed to us, right? Alright, so lamina faces we talked about, right? But that would be two faces that are pointing in opposite directions. right? Like this, and then merge together. Duplicate faces are a touch different. If I just select one and hit Shift D, and then again try and clear my selection, right? By thinking, oh, I didn't actually want to Shift D. I'm going to clear my selection. It's going to place that back at that location, and we actually end up with two faces sitting on top of each other, right? You can sort of see if that I'm in the, what is it, I think it's up here. Yeah, if I'm in the wireframe view, you can notice how most of these faces share a similar tone, but then some of them are slightly brighter, right? If I keep duplicating faces on top of each other, you'll see that that face gets brighter and brighter and brighter, right? That's because there's like a whole bunch of faces stacked on top of each other, and there's a subtle increase in brightness each time, right? So basically, as you're working, if you notice any faces that are doubled up like this, these are an indicator that there is some actually pretty substantial problems on the inside, right? But they're slightly different from laminar faces, just sort of keep that in mind, right? The other one is like something we would call a non-planar face. Now, truthfully, almost all of your polygons are going to be non-planar, right? Like this polygon here is remarkably planar, so that was a bad example. But this one here is non-planar, right? It has some level of bend to it. And we talked about before how quads have surface ambiguity, right? Normally when you're modeling, your faces are going to be maybe say this non-planar, about, you know, there'll be some level of non-planarity, but it's going to be pretty diminished. And in general, it's not going to really contribute to the final object, right? Or it's not going to severely impact the final object. If I was to drag this vert up significantly, this is now what we would consider an error. This is a highly non-planar face, which may triangulate sort of this way, or this way. And we don't know which is going to be which, right? So in general, if you're going to make like a quad this diverged, this non-planar, it should be comprised of either two triangles, right, split like this, or you should actually redesign the area so that you don't have to have this error. But you should never have one single face with this much non-planarity associated with it, right? So that's the other thing. What else? We talked about internal faces before. The basic idea, right, that if I grab this edge and I grab that edge and I hit a face, we end up with a face connecting the two. It's the same for edges, right? If I grab this vert and that vert and hit F, we create an internal edge. This is also considered completely invalid, right? So there's that. We also have overlapping geometry. You can see here how I come back here. We have something that's called z-fighting, right? The basic idea is that one polygon is fighting with another polygon, and because they both exist on the exact same, like, I guess, flat location. I'll show you an example, right? If I grab this face and I duplicate it and I move it only on Z and I offset it a bit, you can see that there's some of this face that isn't overlapping with this, but there's actually a lot in the middle that is. And if I select one, when we start panning the camera, we get this like glitchy effect, right? Because what's happening is that the two faces exist at the exact same depth coordinate for this pixel, right? There's no difference between them discernible by the final render, and so when you actually get to rendering this, you're going to get some like really weird flickering, right? If we give this object some materials, right? I'll give it like a purple material and maybe like a green material, and we go into material preview and actually assign the green material here, this is what the error is going to manifest as. It's going to completely struggle to pick which material, which texture to draw in this location. So this is called z-fighting. This is a really common one, and the basic idea is that if the surfaces are fully stacked in the exact same place, that's an error. We consider that an error, right? So in terms of edges, very similar to the faces, right? If I was to duplicate this edge and stack it sort of on this object over and over again, let me get rid of these materials actually, sorry. We would consider this an invalid piece of geometry as well. And the smoke that we're going to see here is that when I select this, we see like an internal edge like this. We would never expect to see this. Blender is only ever going to show the outside, right, the exterior. If I select these verts as well, we also see that we don't have that like orange glow kind of coming off to the neighboring verts, because there's all this extra junk geometry sort of hidden away in there, right? Sorry, I'm just reading. That's basically it. Okay, so yeah, we kind of touched on the common causes, right? The common cause for this is almost always going to be you decide to perform a command and then you hit escape to clear it, thinking, it's gone. But what you've actually gone and done is you have finished the command, you have duplicated the geometry and then snapped it back, right? This, I believe, is the same for all tools. So if I extrude this and then hit escape, or I extrude it and hit right click, what I'm just doing is just creating extra geometry here, right? This should be the same for insetting as well, right? If I inset and then hit escape, oh, inset might not behave this way. Okay, but I would still be very cautious, right? I still wouldn't be canceling things just by hitting escape or hitting right click, right? Let's try bevel. So we'll bevel it and then we'll hit escape. Yep, so see how bevel and inset actually seem safe? So there's a little bit of like ambiguity here between the commands, right? So I guess stuff that creates geometry, oh, I mean, that's not even exactly true per se, but that's sort of the way I think about it, right? Anything that creates geometry, like an extrusion or a duplication, you have to effectively control C this. You can't just hit escape or right click. So the true way that you would cancel this, right, is you go, okay, I've extruded here. Actually, I don't want to do this extrusion, right? I'm going to left click to finalize it, and then I'm going to control Z to undo it, right? Now it's gone. Now this face is like totally fine, right? So that's probably almost always going to be the major cause of this sort of stuff. There's other things as well, but those ones are going to be much more obvious and very easy to fix as it's happening, right? I want to quickly touch on the mirror modifier as well because there's some unique sort of bugs associated with that, right? If I chuck a mirror modifier on this cube and I think, right, I want the x-axis to be mirrored, I'm going to now start, sorry, we'll do the y-axis just for this demo. I'm now going to start doing some 3D modeling and I have my symmetry working, right? What you might not have noticed is that I never deleted the full half of this cube and we still have this geometry here. When I eventually apply the mirror modifier, we've now created coincident vertices, we've also created interior faces. There's actually a lot that's really bad here, right? So the long and the short of it is, when we work with the mirror modifier, we make sure to fully clear one side of the object first, right? So I'll get rid of all that. We've split this object in half, now it's safe to mirror, right? But even still, we might decide, okay, well maybe I want to put a loop there and I want to extrude the little bit of front out of here, and then maybe we'll do a little bit on the top too, something like that. What we've actually gone and done is we've made a bunch of interior faces here by accident. Right? If I toggle the mirror modifier off, you can see here that I've got these three. Right? I've accidentally put interior faces inside of this object. Right? Now the reason I've done that, I believe, is because this clipping setting wasn't flagged. Right? If I flag, oh, another error there that you can see, right? I've tried to collapse this by hitting Control Space and then F. That's going to sort of make a face out of all of these like polygons. That collapsed almost all of the polygons, but made a completely non-planar edge with Z fighting here, and then I would immediately follow that up by Control Xing these verts to dissolve them down, and that will fully clear the error, right? So back to what we were talking about before. If I run an extrusion here with clipping turned on, and then I have a look, there's no interior faces, right? So I'll do this again. If I turn clipping off and do an extrusion, interior face, right? If I turn clipping on and do an extrusion, it's left an interior face there because that came off of the back of this interior face. But if I delete this, and then turn the mirror modifier on, and then leave clipping on, and then do an extrusion, turning mirror modifier off, we see that there's no internal face, right? So these little things you just sort of learn to like recognize over time, right? Okay, so that's kind of how to identify the errors and how to make them, but now how do we actually fix them, right? So this is where it gets a little artistic and a little bit complicated, right? One of the first commands you're going to learn all the time, I believe, is from I forget what menu they put it in, but if I select this object and I press F3 to search and I search for flip normals, oh sorry, not flips, I want recalculate normals, I can choose if I want to recalculate outside or inside. Okay, Alt N should be the normals menu here. Alt N brings up the normals menu. I can recalculate inside or outside. Basically, that's going to tell Blender, take this object that you see and fully determine which is the inside or the outside, right? So Alt N, I'm going to hit recalculate outside. Now that has done a mostly good job of clearing these out, right? But it hasn't done a perfectly good job of getting rid of all this stuff either. And the reason that it hasn't done that is because the geometry is so fundamentally broken that we actually need to clean it up. Blender's auto magic commands aren't going to work, right? That's another piece of smoke. If you perform a recalculate inside or an outside, there should almost never be a reason for that to fail. Almost never a legitimate reason for that to fail and not succeed. If it does fail, then you suddenly are aware that there is going to be a larger error, like hiding underneath this mesh, right? So we also have the ability to go up here and go to the select menu. We can select by trait non-manifold. So if you do a non-manifold selection and then go into wireframe, you can start to see all of the broken geometry, right? Non-manifold geometry is the big one. Please keep a note that boundary edges are also non-manifold. Now, these are not universally considered an error, right? Sometimes we need the boundary errors, but in things like 3D printing, they're considered a total error, I believe, and a print will fail, or it will fail to slice, right? For a game, though, open boundaries are quite acceptable. So when you do the select non-manifold command, it's also going to grab those, so just keep that in mind, right? But in general, no model should ever highlight like this, sort of like a Christmas tree, right? The reason that this is showing like this is because I have made this mesh as broken as I possibly can, right? But that's how you find them. Sort of select non-manifold up here, right? There's also other selections that we can do here. Interior faces, loose geometry, and then faces by side and pole count, right? If I select interior faces, you'll see that it will select only the interior faces here, but these are also a form of non-manifold geometry. So there's going to be overlap between these two, right? But for instance, if I select nothing, and I go into face mode, and then I go select all by trait, interior faces, I can now press X followed by F to just remove all interior faces, right? Across the whole model. And interior faces are always considered an error, right? You never want them by any reason, okay? The other one, if I just duplicate these faces and stack them on top of each other a bunch, right? If I go select all by trait loose geometry, we see here that these all become flagged, right? We're selecting loose geometry here because these aren't actually merged into the original stuff, right? They're just kind of sitting off to the side. I'm now free then to press X and then F and delete those, the loose geometry, right? If I duplicate this face over here, however, I go select all by trait loose geometry, it considers this edge sort of this face loose geometry. Now this face might actually not be loose geometry because this could be something like an eye highlight that we've decided to put there, or or it could be a floating piece of detail or a decal that we've put there. So floating geometry is a little interesting in that using the selection process isn't always going to get you exactly what you want, so you have to be a little bit careful with it, right? There is also, if I move over into vertex mode, select all by trait, poles by count. Poles are not universally bad, right? But it sometimes is going to help if we can select them and see what's going on, right? If in the select by pole count menu I change from type to equal to, I can then say, right, show me all of the 5-sided poles, show me all of the 6-sided poles, all of the 7-sided poles, so on and so forth, right? So this can really help to see where the poles are in your object, okay? There is also, if I select everything, and I believe it is the select by trait, I forget where it is, but more often than not, I'll just search for select boundary loop. That's going to take whatever I currently have selected and nail it down to just the boundary loop, right? If I select these pieces over here and then do select boundary loop, it's going to select the boundary loop of whatever I had currently had selected before, which isn't a boundary loop. It's just that it was the boundary loop of this selection, right? So that's why when you're looking for boundary loops by selection, you want to select everything by tapping A and then run the edge loop, right? I'm going to try and make a boundary loop here real quick that isn't one that we would want, right? So I've just beveled that out, and then I'm going to scale these to 0. I'm going to shrink all those verts back. And there's still verts here stacked on top of each other, but we're going to shrink them all in, right? Now when I run my selection, select boundary loops, we can see that it's selected our legitimate boundary loop, but it's also selected this area here. This is like a phantom boundary loop, right? So that's not good. We will want to get rid of that. Now, one of the easiest ways you can get rid of this, right, is I can run something called merge by distance, right? So if I know that all of these verts here and all of these verts here comprise a boundary loop, and I can see that by moving one over. If I select all of these, hit F3, and then go to, sorry, not F3, I go merge by distance, and I set this value incredibly low, you're going to see that Blender removed 4 vertices. It basically said all of the coincident verts that are stacked on top of each other within this threshold, I'm going to merge them all down together, right? Now if I select everything and go select boundary loop, nothing shows up. Well, nothing shows up where we expected that invalid boundary loop to show, right? So that's a really powerful tool, is selecting your mesh that you know has problems, right? Like if I duplicate some more faces here and stack them on top of each other, select everything, and then go M menu by distance, you can see that highlighting, that little extra factor here, that little extra brightness that shows up, right? That's all gone now because it's grabbed all of these verts that were stacked on top of each other and just smushed them together, right? Now, when this happens, you may actually end up with some like normal issues, right? You may have ended up creating some normals that were inverted or hanging around. So as long as you've got that normal visualization method on, then you know, you should see everything all good, right? What else have we got? There's something else that you can do here which is a little bit different, right? It's not super intuitive, but if I add a modifier and I search for subdivision and I add that, you're going to see a lot of things that look a bit weird. And I'll actually introduce some more errors here, so I'll turn this off. All right, grab some of them. Cool. Now if I smooth this, do you see what our mesh looks like? It looks like a lot of junk, right? Sometimes it's beneficial just to put a subdivision modifier on your model and just have a look at how that behaves, because this will show you where a lot of smoke is, right? We can see this edge here. We would expect this geometry to all smooth out under a subdivision, but we end up with like pinching up here, right? Why could that be? Well, if I go to this vert, I zoom in on it, and I have a look inside, it's because there's actually this edge here that's running internally, right? Sort of a bow tie vert, right? If I delete this edge, we can now see that the smoothing returns to normal, right? As we would expect, okay? We also have these weird little disk things, because these polygons are not actually merged into the overall shape. These are floating faces, right? Sacked faces. When these are smoothed, they're just going to smooth on their own because they're technically a separate mesh. They're not actually a part of the base mesh, but they kind of look like they were without the modifier, right? What else do we have? You know, we have more pinching up here, showing an interior edge there that's connecting actually a lot, right? We've got this vert here, which is connecting off to here, and blah, 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 blah. So sometimes using subdivision is going to be really easy to show up where these errors are, right? Okay. So I'm going to leave it there. That's a very, you know, theory-laden episode for you, but this is really important stuff. This is like your first major topological hurdle, and this is going to trip up every beginner that gets into Blender when they're trying to follow tutorials and all this sort of stuff, right? I want to just quickly recap on some of the mindsets, like the mindset issues here that you're going to have to accept, right? 90% of your problems are going to come from accidentally canceling commands without effectively Control-Zing them, right? So we need to finish our command and then Control-Z that command to undo it, right? The problems are also going to continue because you're not going to be able to see them as they're occurring, right? Unless you have face orientation flagged. So keep this on and keep paying attention to those smoke, the smoke that indicates fire, right? Clean topology from the get-go, like from the outset, is much easier. Sorry, correct mesh integrity, I guess I should say, is going to be much easier to maintain and work with than it would be to fix broken topology. Like this object is quite broken, and actually going through and fixing this is more often than not more trouble than it's actually worth, right? So sometimes it actually is more beneficial to simply start again, but with valid geometry, right? Because you can sort of see here how easy it is for me to recreate a very similar shape to this one, right? It only takes a few seconds some of the time, right? Now, obviously we don't want to be redoing work, but you can see how I've just gone and made geometry which is perfectly valid with none of these internal errors, and it only took a fraction of the time, right? So fixing, sometimes deleting your work and just starting again, or deleting pieces of your work is easier than fixing it. So for example, like all these broken faces in here, rather than trying to fix these and triangulate them off, I would just select the broken geometry and delete it completely, which is going to reveal more broken geometry. And I'm going to delete that, and I'm going to continue deleting broken geometry in the region until I can tell that there's no more really drastically broken stuff, right? Chuck on a subdivision. Yep, that behaves as expected. Cool. Now I can grab these and start fixing this area, right? So that's the common approach is going to be just getting rid of the geometry first and then rebuilding it, right? Yeah, and your experience as you model is going to teach you like pattern recognition skills and interaction with the program such that these errors stop becoming a thing, right? You will, after a couple months of actually modeling, you will, for the most part, completely stop making these errors, right? So yeah, that's basically Mesh Integrity 101 essentially, right? What I would like you to do for your homework is I will give you this really broken blend file, and I want to see a fixed up version of the model that I give you the next time that we have our session, right? Okay, good luck.